Hello and welcome to Applications and Benefits of the High Definition Stream Survey. My name is Brett Connell, along with Dr. James Parham. The High Definition Stream Survey method started to develop in 2010 after my 6 years of traditional sampling for several organizations throughout the United States. For my thesis at the University of Tennessee, I was tasked with finding a solution to the many issues of traditional sampling. As many of you have experienced, most habitat assessments are done near a bridge or road due to lack of access points. Anybody who has ever traveled downstream understands that these areas are not representative of the entire stream. Due to being on foot and issues with private property, most assessments rarely reach the full 200 meters, which is considered to be the minimum to achieve a quote-unquote representative sample. Because you're on foot, wading through the water with a measuring stick and tape stretched across the stream, a large amount of time is spent calling out measurements to a person with a pencil and paper that will need to be manually entered into the computer at a later time. There are also plenty of rivers and streams that need both bathymetric and habitat information, which are either too wide or too deep to wade across. In the end, decision makers working on a watershed have to rely on somebody else's interpretation of the field measurements from a 200-meter survey and a dot on a map. A perfect example of this is the 2012 Cahaba River TMDL report. There were only 16 sample locations on the main stem of the Cahaba River, all of which were at bridges and roads. If they actually covered the whole 200 meters for each rapid geomorphic assessment, this means only 3% of the river was actually surveyed. Here is a figure showing the relationship of precision versus accuracy. Traditional stream measurements are very accurate and precise at that bridge or road crossing. But to think a 200-meter survey at that location is representative for miles up and downstream is just untrue. Not only did we survey 53 miles of the Paint Rock River in 3 days, we covered 100% of the river and also have the ability to put every one of you sitting in front of a computer on the Paint Rock River to see the conditions for yourselves. What makes high-definition stream survey? There are cameras pointing left and right towards the stream bank, continuously recording bank condition, infrastructure, point and non-point sources, as well as any other parameter that could possibly be monitored. The forward video is recording pool, riffle, run habitat types, canopy cover, and again, any other type of impact that you would like to have georeferenced. The downward-facing camera allows us to assess substrate type, embeddedness, aquatic vegetation, and others, and if turbidity and depth won't allow for visual classification, advances in side-scan sonar technology allow us to georeference numerous channel characteristics throughout an entire reach. The depth transducer records a measurement every second, allowing us to not only continuously gather information while traveling downstream, but to also gather cross-sectional measurements at any requested increment. Improvements in water quality sensors have allowed us to record numerous water quality parameters at 1-second intervals. Including this in the HDSS setup will help us understand what is influencing water quality and where to focus efforts to reduce pollution. Most importantly, GPS is used to tie all of this information together, which depending on the type of unit can record within 3 millimeters of vertical and horizontal precision. High-definition stream survey is a system that can be used on a kayak, canoe, motorized boat, and even a backpack setup for streams with very shallow depths. Right now, while sitting in front of your computer, you are taking a tour of the Collins River and seeing the exact conditions of August 11, 2016. You are able to see left and right bank conditions, habitat type, substrate type, embeddedness, and submerged aquatic vegetation. Side-scan sonar displays the overhead map, depth, and substrate imagery. The only data not currently displayed are all of the water quality parameters which can be added to this very customizable template. The ability to survey 100% of the river and put the decision makers in the actual body of water that they are affecting is incredibly important. Speaking to any organization within water resources, you will always hear that we need more data and we have less funding. High-definition stream survey not only delivers more data with less cost, but also better, more representative data due to being able to see 100% of the river. This is an example from the Harpeth River HDSS where the data table we delivered was 26 columns wide and 96,000 rows long. Each second of video is represented by a time, latitude, longitude, elevation, depth, and several other parameters including water quality measurements. The list of parameters that can be assigned to each GPS point is extensive and keeps growing with every project. Using the HDSS video coding software, we are able to assess any number of parameters and assign the exact GPS location where changes occur. Our post-processing time depends on the number of variables being assessed, which is also the number of text files that need to be combined and georeferenced. Here is the track log from our 80-mile Harpeth River survey, which was completed in 5 days with only 2 people. Of the 96,000 GPS points, you can see the unique information for the exact location where this photo was taken. The following are examples of different parameters typically documented during the high-definition stream survey. This habitat type example is a riffle. This habitat type is a run. This habitat type is a pool. Here are some examples of substrate types that can be assigned to each GPS point. A typical Wentworth scale is most commonly used and is also applicable to the side-scan sonar imagery. Here are some examples of embeddedness according to the US EPA guidelines. These are different levels of bank conditions which can be assigned to each GPS point. These levels are based off of numerous other assessment protocols which enable for fast and efficient classification. Most importantly, however, is locating areas such as this which are contributing large amounts of sediment and nutrients. In terms of precision and accuracy, does it matter if I say this stream bank is 10 feet high when it's actually 11 feet? Or does it matter that you are doing a point sample 3 miles downstream and never would have documented this? After surveying 100% of a stream, these areas can be highlighted, prioritized, and properly addressed instead of never being documented due to the restrictions of traditional sampling. Here is an example of the water quality output and how we had it set up for the Falling Water River HDSS. Specific conductivity was in a certain range traveling downstream, but a drastic change was documented after going up into the Pigeon's Roost Creek. Just upstream of this confluence is the site of a water treatment facility that was having issues staying within clean water standards. Survey grade measurements are made possible by connecting a GPS rover to the RTK network. Combining this GPS with our depth sensors will provide extremely accurate water surface elevation measurements throughout the entire reach, but can also be combined with cross-sections to provide bathymetric measurements for modeling purposes. Not only can we gather this information for any chosen increment on the main stem of a river, but we also can paddle into the tributaries to gather cross-sectional measurements of the incoming water. High-definition stream survey allows for a single survey to gather information for numerous organizations for numerous applications. HDSS documents infrastructure for MS4s and the Department of Transportation. HDSS gathers precise bathymetry measurements for water quantity and water quality modeling. HDSS gathers habitat information, which can be used to prioritize mitigation, as well as locate or reintroduce threatened and endangered species. HDSS also enables anybody to virtually tour a river in order to see what types of impacts are affecting the stream and to what degree. High-definition stream survey allows us to easily zoom in on areas of concern and quickly see what types of impacts are happening where. With over 61,000 data points from the 53-mile Paint Rock River HDSS, it may seem difficult to know exactly where to invest your time. However, within GIS, sites can be easily ranked according to numerous different factors. Because each GPS point is a unique set of data, tributaries and stream segments can be grouped and compared against each other. The HDSS can also be broken down into 1-kilometer sections and even 200-meter reaches. Because each 200-meter section had its own unique bank condition score, we are able to easily rank from the worst bank condition to the best. For this project, we delivered the top 10 worst 200-meter segments for bank condition on the right and left. In order for many organizations to do any work on a stream, there needs to be a willing landowner. If number 269 was the worst and didn't have a willing landowner, you can now easily move on to the next worst site and proceed accordingly. In total, 425 individual 200-meter segments were created from the data that was gathered in only 3 days. This compared to traditional assessments where 1, maybe 2, 200-meter sites could be completed in a day, shows HDSS with an efficiency of 140 to 1. Now getting back to site number 269, the Nature Conservancy has since done a restoration project on a site prioritized by the high-definition stream survey. With all of the funding put into restoration, we now have an economical way to not only find the areas in most need of restoration, but to also monitor those sites after improvements have been installed. Being able to measure the ecological lift along with the amount of money invested will help prioritize restoration methods for future projects. The importance of partnerships is becoming more and more evident every day. Most of our projects are funded by multiple agencies, which in the end will result in more data at a lower cost for everyone. Truda Environmental Solutions, developers of the High Definition Stream Survey, bringing you more data, higher quality at a lower cost. Contact us at info@trudasolutions.com.